Hello students, welcome to a course on engineering graphics. This session is an introductory class on projection of planes. In this class, we will try to understand how to read the problem statement on projection of planes and analyze the problem statement. Lamina is a geometrical figure with less thickness. The geometrical figure can be a triangle, square, rectangle, pentagon, hexagon, circle, etc. The figure here shows a hexagonal lamina placed in first quadrant. This is a horizontal plane and this is a vertical plane. The intersection of these planes is called as the reference axis, usually indicated by XY. When lamina is made parallel to a plane, then the actual or true shape of the lamina can be seen. If the lamina is made parallel to horizontal plane, then the actual dimensions of the lamina can be seen in the top view. If the lamina is made parallel to vertical plane, then the actual dimensions of the lamina can be seen in the front view. Here, the top view projection of hexagonal lamina is shown. The corners of top view are named with small alphabets A, B, C, D, E, F taken in order. The front view of the lamina is projected on the vertical plane. This corner A is visible from this direction. So it is named as A dash. This corner is hidden behind A. It is named as B dash in bracket. Similarly, this corner F dash is visible and this corner C is hidden. So it is written in bracket. E dash is visible, D dash is hidden. Top view is drawn on horizontal plane and front view is drawn on vertical plane. This figure also represents hexagonal lamina in first quadrant, but the hexagonal lamina is placed on horizontal plane. In such a case, the front view will be drawn on the reference line or reference axis. This figure shows a general layout of the problem solution. The problems on planes is usually solved in 3 steps. First step is referred as first position, second step is referred as second position, third step is referred as third position. In first step, the lamina is made parallel to one plane. The top view and front view are drawn. In second position, the inclination to the plane to which the lamina was made parallel is considered. In third position, the inclination with the other plane is taken into account. Also, whether a locus method or it is not a locus method is decided in the third position. The problem statement can be analyzed in 3 steps with respect to the 3 positions. In the first position, we will check which type of lamina is given. That is, whether it is a triangle, square, hexagon, pentagon or circle. Then we will check whether the corner or side of the lamina is resting on HP or VP. If the corner or side is resting on HP, the lamina is made parallel to HP. Means we will draw the true top view. If the corner or side is resting on VP, The lamina is made parallel to VP, means the actual lamina dimensions can be seen in front view. Second position, first inclination is given to surface, bisector or median or diagonal. Surface is an area enclosed by the sides of a polygon. Bisector is a line drawn from a corner to the opposite side. This line divides the side into two equal halves. Diagonal is line drawn from one corner to other corner. If lamina is made parallel to HP in step 1, then the first inclination with HP will be taken. If lamina was made parallel to vertical plane in step 1, then first inclination is with VP. Third position, if bisector, median or diagonal is inclined to the other plane, then it is a locus method. If bisector or median or diagonal appears to be inclined to other plane, then it is not a locus method. If these words appears to be inclined are given. If the second inclination is given to a side or edge, then it is not a locus method. This figure shows lamina resting on its sides on HP. The laminas are made parallel to HP and the top view and front views are drawn. These figures are when lamina side rests on VP, then the actual shape of lamina is seen in the front view and top views are also drawn. These figures show corner of lamina resting on HP. Again the lamina is made parallel to HP and top view will give us the actual shape of the lamina. These figures are with corner resting on VP and the lamina actual shape can be seen in the front view.